Hello everyone, welcome to day 6 of Data Science Week by Simply Learn. On day 5, we understood about machine learning for data science. Today we are going to learn another very crucial data science skill, that is deep learning for data science. Deep learning is a part of machine learning that uses vast volumes of structured and unstructured data to train models. Data scientists should know how to train artificial neural network models such as CNN, RNN, GAN, LSTM using libraries such as TensorFlow and Keras. We are going to learn all these topics today. So let's dive in and understand deep learning for data science.
Let's get started. So what is deep learning? Again, this video is not about deep learning, but there are other videos we have created in detail about what is deep learning. In this video, we'll just touch upon the basics, so that's like a nice segue into TensorFlow. So deep learning is in a way a subset of machine learning, and we use primarily neural networks in deep learning, and the underlying technology behind artificial intelligence is deep learning. And here we teach them how to recognize, let's say, images or voice and so on and so forth. So it is a learning mechanism, but here, unlike traditional machine learning, the data is far more complicated and far more unstructured. Like it could be primarily in the form of images or audio files or text files. And one of the core components of deep learning is neural network. And a neural network somewhat looks like this. There is something known as an input layer, and then there is an output layer, and in between there are a bunch of hidden layers. So typically there would be at least one hidden layer, and anything more than one hidden layer is known as a deep neural network. So any neural network with more than 3 layers altogether, right, is known as a deep neural network. All right. So what are the functions of the various layers? Let's take a quick look. So the input layer accepts the input. So this could be in the form of, let's say, if it is an image, it could be the pixel values of the images. So that's what the input layer does. And then it passes on to the hidden layers. And the hidden layers in turn perform certain computations. And they have what is known as a part of the training, they have these weights and biases that they keep updating till the training process is complete. And each neuron has multiple weights and there will be one bias, and these are like variables, and we will see when we go into the TensorFlow code what we actually mean by that. And so that's what the hidden layer does. It does a bunch of computation and passes its values to the output layer, and then the output layer in turn gives the output. It could be in the form of a class. So for example, if we are doing classification, it tells us which class a particular image maybe belongs to. For example, let's say if this is a image classification application, then the input could be a bunch of images of maybe cats and dogs, and the output will be like, it will say, okay, if this is activated, this gives a 0 and this gives a 1, that means it is a cat. If this gives a 1 and this gives a 0, that means it is a dog. So that is a kind of a binary classification, and that can be extended with multiple neurons on the output side to have many more classes, for example. Or it can also be used for regression as well, not necessarily only classification. Again, since this video is not about deep learning or machine learning or neural network, we will probably not go into a lot of details, but you can check other videos where we have given a lot more details about neural networks and deep learning and so on. So in order to develop a deep learning application, how do you go about? Primarily, there are 2 or 3 components that are required in order to develop deep learning application. You need obviously a programming language. So typically Python is used, and that's what we are going to use in this particular video, but you can also use other languages like Java or C++ and so on. And there are some libraries that are readily available and primarily for doing machine learning and deep learning programming. So these are a list of libraries. These are by no means the exhaustive list, but some of the most common ones like Keras, Theano, TensorFlow, and so on and so forth. TensorFlow has nowadays become very, very popular. This is developed by Google, and it is an open source library. And Keras was there before. Now Keras has actually now become a part of TensorFlow as well. So it is one layer above TensorFlow. So in that sense, they're well integrated. So a combination of Keras and TensorFlow is pretty good. Then of course you have Torch and DL4J and so on and so forth. So there are multiple libraries, but this video is about TensorFlow, and we will be focusing on TensorFlow. What are the benefits of TensorFlow and what are its components? And towards the end, we will show you a code in Python. We've written a code in Python. By the way, TensorFlow can be used with multiple languages. It supports multiple languages, though Python is by far the most popular language. So let's take a look at what exactly is TensorFlow and why we are so excited about TensorFlow. So TensorFlow offers APIs. Now we can, earlier when these libraries, none of these libraries were there. Even then people were doing machine learning and deep learning and so on. But the coding mechanism was much more complicated. What these libraries like TensorFlow offer is they provide kind of a high level API so that we don't have to go really deep into writing all the stuff that is required, let's say to prepare a neural network and to even configure or even to program a neuron and so on, right? So these are done by the library. So all you need to do is they offer a higher level API. You need to use that API and call that API and maybe pass the data, and that would it's much easier rather than actually going down and writing everything by yourself. So TensorFlow, that way it offers APIs to write your code in Python or even C++ and so on, other languages, Java as well. It has an integration with R as well, apparently, okay? And it supports CPUs as well as GPUs. Now, deep learning applications are very compute intensive, especially the training process needs a lot of computation. It takes very long, as you can imagine, because the data size is large and there are so many iterative processes. There are so much of mathematical calculations, matrix multiplication, and so on and so forth. So for that, if you perform these activities on a normal CPU, typically it would take much longer. But GPUs are graphical processing units. You must have heard GPUs in the context of games and so on, because where the screen needs to be of high resolution and the images need to be of high resolution and so on. So GPUs, as the name suggests, graphical processing unit, were originally designed for that. But since they are very good at handling this kind of iterative calculations and so on, now they are being used or leveraged rather for doing or developing deep learning applications. And TensorFlow supports GPUs as well as CPUs. So I think that's one of the major advantages of TensorFlow as well. Now, again, what is exactly TensorFlow? It's an open source library developed by Google and open source, and primarily for deep learning development. But TensorFlow also supports traditional machine learning, by the way. So if you want to do some traditional machine learning, we can do it. However, it is probably a bit of an overhead to use TensorFlow for doing traditional machine learning, and this is really good for performing deep learning activities. And again, if you want to get into more details about what's the difference between machine learning and deep learning, there is another video about it. You can probably take a look at that video. What else? It is developed originally for large numerical computation. So originally when TensorFlow was developed, they never thought of it as keeping deep learning in mind, but ultimately it so happened that it's really very good for deep learning development, and therefore Google has open sourced it. And TensorFlow, as the name suggests, the data is in the form of what is known as tensors. These are like multi-dimensional arrays, and they are very handy in handling large amounts of data, and we will see that as well as we move forward. And then of course the execution mechanism is in the form of graphs, so that makes it much easier to execute this code in a distributed manner across a cluster of computers and also using GPUs and so on and so forth, right? So that's a quick overview about what is TensorFlow. We will see a little bit more detail the two major components, that is basically the tensors and the graphs. Let's take a look at what they are. So what are tensors? Tensor is, as I mentioned earlier, it is like a multi-dimensional array in which the data is stored. Now when we are doing deep learning, especially the training process, you will have large amounts of data, and the data is typically in a very complicated format, and it really helps when you are able to use this or store it in a compact way. And so tensors actually offer a very nice and compact way of storing the data, handling the data during computation. This is not really for storing on your hard disk or things like that, but in memory when you're doing the computation, tensors are really very handy in terms of keeping the data compact, because they are like multi-dimensional arrays. So the data is stored in tensors, and then it is fed into the neural network, and then you get the output. All right, so there are some terms associated with tensors, let's get ourselves familiarized. One is the dimension and another is the rank. So what is dimension? Typically, dimension is like the number of elements in a way. So for example, this is a 5 by 4 dimension tensor, and then you can have again multi dimensions, right? So this can be like 3 by 3 by 3. So that is the dimension. And then you have ranks. What are tensor ranks? Ranks are basically, traditionally we would have thought of as dimensions. That is actually, in this case, it is called rank. So it becomes easier when we see examples. So a tensor's rank is supposed to be 0 when there is only one element. We also call this as scalar. So just one element, and this is not really a vector, it's just an element like 200. It's also known as a scalar. So such a tensor is supposed to be having a rank of 0. Then you have, let's say, a one-dimensional array. This is a vector with a row of elements. This has rank of 1. Now if you have traditionally what we call as two-dimensional, like a matrix for example, then the rank is 2, and in this case the rank is 3. And it can have more ranks as well. As I mentioned, it is like a multi-dimensional array, so you can have rank 5, 6 and so on. Okay, so those are the terminologies in TensorFlow terms: dimensions and ranks. So this is just to make sure that we are speaking the same language, so whenever we talk about a rank of a tensor, you understand what exactly is meant by that. Now, in addition to tensors in which the data is actually stored, all right, so the data is stored in the tensors, and then once you have the data, there is a computation that needs to be done. Now the computation happens in the form of graphs. So what we typically in a TensorFlow program, what we do is, it's not like traditional programming where you just write a bunch of lines and then everything gets executed in sequence. Here we prepare graphs, various nodes, and then these are executed in the form of a session, and they use the data from these tensors. Now I know this is a slightly new concept for a lot of you, so it may be a little difficult to probably understand in the first cut, but when we look at the code, when we go into the tutorial, the code walkthrough, I think that time it will become much clearer as well. But to start with, just we need to keep in mind that we have to first prepare a graph, and when you're preparing the graph, none of the code is actually getting executed. You write the code to prepare the graph, and then you execute that graph. So that's the way, by creating a session, that's the way TensorFlow program works. So, and each of these computation is represented as what is known as a data flow graph. And we will also see that whenever you start TensorFlow, when you create an object, TensorFlow object, there will be what is known as a default graph, and then if required, I know probably in the beginning it may not be required, but in more advanced programming you can actually have multiple graphs. Instead of the default graph, you can create your own graph and have multiple graphs and use it as well. But there is always, whenever you create a TensorFlow object, there will be a default graph, and this will be very nicely illustrated in the example code that we will take to explain this. So there it becomes much clearer than in these slides. So the graph gets executed and it processes all the data that we are feeding. All the external data will be fed in the form of what is known as placeholders, and then you have variables and constants. Again, this will also become clear when we take a look at the code. And once you have the graph, then the execution can be enabled either on regular CPUs or on GPUs, and also in a distributed mode, so that the processing becomes much faster. As I mentioned, the training of the models in deep learning takes extremely long because of the large amount of data, and therefore using TensorFlow actually makes it much easier to write the code for GPUs or CPUs and then execute it in a distributed manner. So this is how the TensorFlow program looks. So there is you need to build a computational graph. That's the first step, and then you execute that graph. So the first step is to write the code for preparing the graph, and then you create what is known as a session, and then in that session you ask the session to execute this graph. So this will again become much clearer when we look at the code.
Before we can see the differences between these platforms, we first need to know what exactly each of these platforms are. Let's start with TensorFlow. What is TensorFlow? TensorFlow is a low-level software library which is created by Google to help implement machine learning models and to solve complex numerical problems. TensorFlow is nothing but a free and open source software library for machine learning. It can be used across a range of tasks but has a particular focus on training and inference of deep neural networks. TensorFlow is a symbolic math library based on data flow and differential programming. It is used for both research and production at Google. What do you mean by data flow? It basically means that we perform calculations by converting every element into graphical form. The variables of the graph are called tensors and mathematical operations are called operators. Here, in the computational graph shown, you can see that x, y, and 2 are the variables. They will also be called tensors, and division, multiplication, and addition are the operators. This graph basically shows us the calculation that is going to occur in a machine learning model where x and y are going to be divided and y and 2 are going to be multiplied. The results of these two calculations are then going to be added to give us the final output. I told you that x, y, and 2 are also called tensors. What exactly are tensors? Tensors are multidimensional arrays with a uniform type. All tensors are immutable like Python numbers and strings, which means that you cannot update the contents of a tensor. You can only create a new tensor. Next, let's look at the API Keras. What exactly is Keras? Keras is a high-level deep learning API written in Python for easy implementation and computation of neural networks. Keras is an open source software library that provides a TensorFlow interface for artificial neural networks. Keras acts as an interface for the TensorFlow library, which means that it runs on top of TensorFlow. Up until version 2.3, Keras supported multiple backends, including TensorFlow, Microsoft Cognitive Toolkit or CNTK, R, Theano, and PlaidML. As of version 2.4, only TensorFlow is supported. As of version 2.4, only TensorFlow is supported. Designed to help enable fast experimentation with deep neural networks, it focuses on being user-friendly, modular, and extensible. Keras is a high-level API of TensorFlow, an approachable, highly productive interface for solving machine learning problems with a focus on modern deep learning. It provides essential abstractions and building blocks for developing and shipping machine learning solutions with high iteration velocity. Keras does not perform its own low-level operations such as tensor products and convolution. It relies on back-end engines for that. Even though Keras supports multiple back-end engines, its primary back-end engine is TensorFlow, and its primary supporter is Google, which means that Keras acts as nothing more but a wrapper class around TensorFlow, Theano, CNTK, PlaidML, or MXNet, which are low-level APIs. Next, we will look at PyTorch. What exactly is PyTorch? PyTorch is a low-level API which is developed by Facebook for natural language processing and computer vision. It is a more powerful version of NumPy. It is an open source machine learning library based on the Torch library used for applications such as computer vision and natural language processing. Primarily developed by Facebook's AI Research Lab, it is free and open source software released under the modified BSD license. Although the Python interface is a more polished and the primary focus of development, PyTorch also has a C++ interface. Python is a widely liked language because it is easy to understand and write. PyTorch emphasizes flexibility and allows deep learning models to be expressed in basic Python. PyTorch is mainly used for natural language processing and for computer vision. Now let's move on to the differences between TensorFlow, Keras, and PyTorch. The first difference that we'll be looking at is called level of API. There are two main types of APIs, a low-level API and a high-level API. API stands for Application Programming Interface. A low-level application programming interface is generally more detailed and allows you to have more detailed control to manipulate functions within them on how to use and implement them, while a high-level API is more generic and simple and provides more functionality with one command statements than a lower-level API. High-level interfaces are comparatively easier to learn and to implement the models using them. They allow you to write code in a shorter amount of time and to be less involved with the details. In this case, TensorFlow is a high and low-level API. Pure TensorFlow is a low-level API, while TensorFlow wrapped in Keras is a high-level API. Keras in itself is a high-level API which uses multiple low-level APIs as a backend and simplifies the operation of these low-level APIs. PyTorch is a low-level API. The next criteria that we'll be looking at is speed. TensorFlow is very fast and is used for high performances. Keras is slower as it works on top of TensorFlow. Not only does it have to wait for TensorFlow to finish implementation, it then starts its own implementation. Meanwhile, PyTorch works at the same speed as TensorFlow, as both of them are both low-level APIs. Now, Keras is a wrapper class for TensorFlow and has added abstraction functionalities on top of TensorFlow, which make it slower than TensorFlow and PyTorch. In computation speed, both TensorFlow and PyTorch are almost equal, and in development speed, Keras is faster as it has built-in functionalities which can significantly reduce your development time. The next difference is on the architecture. TensorFlow is not very easy to use, and even though it provides Keras as a framework that makes it work easier, TensorFlow still has a very complex architecture which is hard to use. Meanwhile, Keras has a simpler architecture and is easier to use. It provides a high level of abstraction which makes implementation of programs in Keras significantly easier. PyTorch, on the other hand, also has a complex architecture and the readability is less when compared to Keras. TensorFlow uses computational graphs which makes it very complex and hard to interpret, but it has amazing computational ability across platforms. PyTorch is a little hard for beginners but is really good for computer vision and deep learning purposes. Datasets and debugging. TensorFlow works with large datasets due to its high execution speed, and debugging is really hard in TensorFlow due to its complex nature. Meanwhile, Keras only works with very small datasets as its speed of execution is low. Programs do not require frequent debugging in Keras as they are relatively simpler, and PyTorch can manage high-level tasks in higher dimension datasets and is easier to debug than both Keras and TensorFlow. Next, we'll be looking at ease of development. As we said before, TensorFlow works with many hard concepts such as computational graphs and tensors, which means that writing code in TensorFlow is very hard. It is generally used by people when they are doing research work and really need very specific functionalities. Keras, on the other hand, provides a high level of abstraction which makes it very easy to use. It is best for people who are just starting out with Python and machine learning. PyTorch is easier than TensorFlow but is still comparatively hard than Keras. It is not very easy to learn for beginners but is significantly more powerful than just plain Keras. Ease of deployment. TensorFlow is very easy to deploy as it uses TensorFlow serving. TensorFlow Serving is a flexible, high-performance serving system for machine learning models designed for production environments. TensorFlow Serving makes it easy to deploy new algorithms and experiments while keeping the same server architecture and APIs. TensorFlow Serving provides out-of-the-box integration with TensorFlow models but can be easily extended to serve other types of models and data. In Keras, model deployment can be done with either TensorFlow Serving or Flask, which makes it relatively easy but not as easy as it would be with TensorFlow and PyTorch. PyTorch uses PyTorch Mobile, which makes deployment easy, but again, for TensorFlow, deployment is way easier as TensorFlow Serving can update your machine learning backend on the fly without the user even realizing. There's a growing need to execute ML models on edge devices to reduce latency, preserve privacy, and enable new interactive use cases. In the past, engineers used to train models separately. They would then go through a multi-step, error-prone, and often complex process to train the models for execution on a mobile device. The mobile runtime was often significantly different from the operations available during training, leading to inconsistent developer and eventually user experience. All of these Frictions have been removed by PyTorch Mobile by allowing a seamless process to go from training to deployment by staying entirely within the PyTorch ecosystem. It provides an end-to-end workflow that simplifies the research to production environment for mobile devices. In addition, it paves the way for privacy-preserving features via federated learning techniques. At the end of the day, the question that really matters is which framework should you use, Keras, TensorFlow, or PyTorch? Now, TensorFlow has implemented various levels of abstraction to make implementation of deep learning and neural networks easy. This has also made debugging easier. Keras is simple and easy, but not as fast as TensorFlow. It is more user-friendly than any other deep learning API, however, and is easier to learn for beginners. PyTorch, on the other hand, is the preferred deep learning API for teachers, but it is not as widely used in production as TensorFlow is. It is faster, but it has lower GPU utilization. At the end of the day, the framework that we would suggest that you use is TensorFlow. Why? While PyTorch may have been the preferred deep learning library for researchers, TensorFlow is much more widely used in day-to-day production. PyTorch's ease of use combined with the default eager execution mode for easier debugging predestines it to be used for fast, hacky solutions and smaller scale models. But TensorFlow's extensions for deployment on both servers and mobile devices combined with the lack of Python overhead makes it the preferred option for companies that work with deep learning models. In addition, the TensorFlow board visualization features offers a nice way of showing the inner workings of your model to, say, your customers. Meanwhile, between TensorFlow and Keras, the main difference isn't in performance. TensorFlow is a bit faster due to less overhead, but also the level of control you would like. Keras is much easier to start with than plain TensorFlow, but if you want to do something with Keras that doesn't come out of the box, it will be harder to implement that. TensorFlow, on the other hand, allows you to create any arbitrary computational graph, providing much more flexibility. So if you're doing more research type of work, TensorFlow is the sure route to go due to the flexibility that it provides.
Welcome to the session on installing TensorFlow. My name is Mohan and I'm going to take you through the process of setting up this TensorFlow development environment. As some of you may be aware, it's not that easy to set up the TensorFlow environment. There are several components, there are several possibilities. For example, you can set up on Windows, you can set up on Ubuntu. Now Ubuntu has multiple versions, which version to use, and then you have Python, which release of Python to use, whether to do a pip install, whether to do install using Anaconda, and how do you then link it up with Jupyter Notebook. These are multiple possibilities and it takes up a lot of time to try all of these. So today what I'm going to do is show you a tried and tested method of setting up the TensorFlow environment. And this will help primarily those who are starting with TensorFlow so that they don't have to waste so much time on setting up the environment and experimenting with the installation and setting up of the environment. Now, what we are going to do is I will show you a method by which it is a tried and tested method. And of course, TensorFlow homepage has an install page and it shows you some ways to install. But again, the challenge is the same. There are multiple versions, multiple methods shown there. So it's highly confusing for somebody who is new as to decide which path to take. So in today's session, what we are going to do is we will set up TensorFlow on Ubuntu, and I'm going to show you in a virtual box. But then if you are using a laptop with Ubuntu installed, you can straight away use the same method. However, we need to keep one thing in mind, that the various releases and versions of Ubuntu and Python and then TensorFlow, not all of them are compatible with each other. So these versions and releases need to be very specific. So I will tell you which is the version and releases, what combination is best suited for you to get started, and later on, of course, you can then experiment with other possibilities and other releases and so on once you get familiar with TensorFlow. To start with, I would also like to mention that it is a good idea to install or start with Ubuntu environment or a Linux, any other Linux also, but here we will focus on Ubuntu rather than Windows. So for those who are already, let's say, using a Windows system, the question may arise, what do we do? But there is an easy option. As you can see, I'm actually using a VirtualBox. So you need to install VirtualBox. Let me just show you. So this is the VirtualBox, Oracle VM VirtualBox. And there are tons of videos on YouTube how to install a VirtualBox and how to create a Ubuntu image. I think we will not spend time on that. But if you're using Windows, and my preference would be to set up a VirtualBox and set up your environment in Ubuntu image. So we will start by assuming that you have an Ubuntu environment, especially release 14.04 LTS. There are multiple Ubuntu versions, and again, we will not try to get the latest and the greatest versions or latest and greatest releases, but the focus here is to take the releases and versions which are working and where you will not waste time. So the setup process will be smooth if you stick to these releases. You can of course experiment later on with other versions and try out, but here we will be working with Ubuntu 14.04 LTS, and we will use Python 3.4, and we will use TensorFlow 1.5. This is a tried and tested combination, and I would also recommend that you use the same if you want a smooth start. And so let's get started with that. Let me log in to my Ubuntu system. Okay, so we have the Ubuntu system running here. Now, if you go to tensorflow.org, there is a page which mentions how to install TensorFlow, and as you can see, there are multiple possibilities. You have Ubuntu, you have Windows and Mac OS and so on and so forth. And if you go to Ubuntu, for example, further you will get multiple options, whether you want CPU or GPU, and whether you want to do pip install or using a virtual native pip, virtual env, Anaconda, and so on and so forth. So all these options are very complicated, or rather they're very confusing, I would say, not complicated, depending on whether you're expert or, of course, I am talking about beginners here. But if you click on some of these options, they may look very easy. So for example, if we go back and if you select, for example, native pip, it may appear like, oh, this is just, one single or two steps and that's about it. Everything gets installed. You see here, it should be just one step install. If you say pip3 install TensorFlow and everything gets installed. Unfortunately, it doesn't work that way. So it's not as easy as, so don't get kind of fooled by the simplicity of the documentation here. Again, it's not their fault because of the multiple combinations of releases and so on and so forth. It is not that easy. So what we will do is we will take a slightly roundabout method, which is using Anaconda, which has a few more steps, but you're sure that this is going to work. So that is what we are going to do, and that's what I'm going to show you. So what are the steps involved? Of course, I will not go exactly by what they have mentioned here. As I said, I will show you the steps which are again sure shot to work, whereas here again, if you follow just this document, there will be some variations which they have kind of not documented. So that's the reason I will show you the steps separately. All right, so these are the main 4 steps. You need to download and install Anaconda, and then create a virtual environment with Python, and the release, as I mentioned, is Python 3.4, and we will install TensorFlow version 1.5, and then we will install and configure Jupyter, which will be our development environment. Alright, so let's get started. This is our Ubuntu, and let's get a terminal started here. And okay, yes, so alright, so we started the terminal, and then what we'll also do is we'll go to the Anaconda website because we need to install Anaconda. We need to download and install Anaconda. So for that, you need to go to the Anaconda website. So you can just open a browser and Google, and you will find the Anaconda website. So this is the site, anaconda.org. Click on this link and it will take you to the Anaconda website. You don't have to sign up or anything like that. Just look for the download Anaconda. So just click on that. It will take you to the download pages and it automatically recognizes that you're on Ubuntu. So it will show you the links to download. Alright, so as you can see, it has recognized that you're on a Linux operating system. So you can just click on this download and it will start the download. There are two versions, of course, Python with Python 3.6 and 2.7. I recommend you start with Python 3.6. Now, just want to clarify that we will be actually using Python 3.4. This is just for the initial installation, but subsequently when we set up the virtual environment, you will see there is one more step there where we set up the virtual environment. There we will actually be using Python 3.4, so just that you're not confused. Alright, so it has started the download. We just say no thanks for this and it is downloading. While it is downloading, you can click on this link saying how to install Anaconda. So there are a couple of steps mentioned there that we will be using. So let me just in the meanwhile click on this. For some reason the network is a little slow, so it is taking time. Alright, so once the download is done, we will be using the options that are mentioned here. Now the first step, of course, is we are already doing the first step, which is downloading the installer for Linux. The second step is not mandatory, so it's an optional step. Most often you can actually skip that. And third step is what we are going to do. And since we are using, at this point, we are using Python 3.6, we should use this command. So basically, the terminal we have opened here is to use or to run this command. That's the reason I opened this terminal. However, make sure that the download is complete before you run this command. So we'll just wait for a couple of minutes and we'll come back once the download is done. Alright, so as you can see, the download is done. This is a fairly large file, so if you're on a slow internet or low internet bandwidth, then it might take quite a while. It's about 578 MB, and so this is the file. Now what you need to do is you need to go back to this installation steps, and let me minimize this, and yeah. So this is the command that you need to run. So you can just directly copy and paste this command from here. Okay, so I do a copy, right mouse click. Now it will ask you a bunch of questions as documented here. So most of them you need to just say enter or yes, and that's about it, except for the last step. I will just show you what we need. And here you need to press enter multiple times just to make sure you agree to all these agreement, the license agreement and so on and so forth. So once you do multiple enters, it will bring you to the next step. Alright. So now here again they say do you accept the terms. You just say yes and then press enter, and here it will ask you a couple of questions, and pretty much you need to just go for the default version. Press enter to confirm. You just say press enter, and this is primarily when it will pretty much start the installation process of Anaconda. This might take a little while depending again on your internet speed, so you need to have some patience. We will also probably come back once this installation is done, or if it asks for any further questions. Alright, so here you'll get again one more question. Do you wish the installer to prepend? So you just say yes for this question and keep going. Now the last question, I think we are pretty much at the end, and that is about Microsoft VSS, I guess. Yeah, VS Code. So for this you can just say no, because we will not be using this, and that's it. You're done. So this is completion of installation of Anaconda. So it's always a good idea to exit and start a fresh terminal. Okay, so let's start again, a terminal. So we are done with the installation of Anaconda, the next step is to create a virtual environment with Python 3.4. So for that, this is the command conda create -n, and this is the name of your virtual environment. You can give any name, but for easy reference I have given as TensorFlow, and we have to specify the Python version. As I mentioned earlier, we will be using the combination of Python 3.4 and TensorFlow 1.5. Now, this is not the latest version. Python has probably 3.6 at this point at the time of creation of this video, and even TensorFlow probably has the latest version as 1.7, but then these combinations sometimes may not work, and I found that after several trials and errors, 3.4 with 1.5 seems to be most reliable, and that's the reason I have chosen this. I would recommend you to try with this first if you're a beginner, and later on maybe you can try out the other permutations and combinations. Alright, one step I just wanted to show you is before we do the installation or creation of the virtual environment, if you want to just clarify or confirm whether Anaconda has been installed or not, you can run what is known as Anaconda Navigator. So you just say Anaconda Navigator. Okay, we need to edit this part. Hold on one second. I guess it is. Alright, so you see here when you start Anaconda Navigator, this Anaconda Navigator will open up. That is an indication that Anaconda has been installed properly. So that's just a quick check, and you don't have to do anything. Just you can go back and close it once this comes up, and then in the meanwhile, let me just open one more terminal for the creation of the virtual environment. And yeah, so this is your Anaconda Navigator, and you can just say okay, don't show me, and you just say okay, and then you can close this. You can say file, you can do a file exit, or you can click on the close button, whichever. Alright, so we will exit from here. We have a terminal open here. We will use this for our next steps. Alright, so what we have to do now is type in this piece of code or this command. For some reason copy paste is not working, so it's a small command, so it shouldn't be that big of an issue. So we say conda, and we say create. So this is the command for creating a new environment /-n, and then we give the name of the environment. So we can give any name for convenience. I'm just calling it TensorFlow, but you can actually name it anything. And then we need to specify with which version of Python. So we say pip Python, and then that is equal 3.4. Okay, so it will create an environment. This will take a little while. It'll ask you a question, just say yes, and then it will be done. So this is just a warning. You can simply ignore that, and for the question that it asks, you just say yes, and I think you should be good. Alright, so it says do you want to proceed? You say yes, and then enter. This will again take a little time, so we will probably move forward and then come back once this is done. Alright, so the environment has been created. Now it's always a good idea to, whenever some of these steps get over or each step gets over, you just exit the terminal and start afresh with a new terminal. For some reason, sometimes it causes problem if you continue. So I found that it is a safe practice to each time exit the terminal and start afresh. Now that we have an environment created, we can, by the name TensorFlow, you can enter that environment by calling the command source activate TensorFlow, or the name, whatever name you have given. So you'll see here, once you do that, you will get this, the name of the environment will be shown here. So it is like your own, again, a special environment within the system. And from here onwards, you can do other stuff like actually installing TensorFlow and so on. And you will see that it has installed Python 3 here, so 3.4, right? So it is installed. That's what we, during creation of this environment, we wanted Python 3.4, so that is what it is showing. But we are not yet done, so we need to still install TensorFlow. So in this environment, you need to run a command which will actually install the correct combination of TensorFlow. Now this is, as you can see, it's a slightly complicated command, pip install -- ignore install. So what we can do is from within here we can go and go to TensorFlow install page, and there is a sample code there. You can pick up from there so that you don't have to type in so much. So we say tensorflow.org. And I'll also open up probably a notepad here so that we can construct that command and go here. We say Ubuntu. If you come further down, there will be, by the way, we are doing CPU installation. I think that is clear. We are not, there is a possibility to do GPU as well. We will probably create a separate video for that. And if we go here, yeah, so again, you probably, if you follow the entire document out here, it may still not work. So I do not recommend that for now, at least for beginners. But just to copy this command, because this is a fairly complicated command, so this is much easier to copy it from here. That's the reason I'm on this page. And we will then modify it according to, yes, okay, let's say copy, and don't do it directly here because that is probably not yet the right command. Let us go and create a notepad page, empty document. I'll just say tf.txt. Okay, this is just a temporary file. What we need to do here is we need to adjust this command to suit the versions that we are installing here. So let me just explain what it is, what you need to do. So first thing, you can get rid of this one. Yes, okay. Now here, these parts you can simply ignore. Here you need to go and change it to version 1.5, and I think we are good with that. Okay, so the CP34 indicates your Python 3.4. So later on, when you're trying to experiment and if you want to do other combinations of TensorFlow and Python version, then you can change this. For example, you can change this to 3.6. Both these places you need to change this to 3.6 if you're using with Python 3.6. And similarly, if you want the latest version, which is of TensorFlow, which is 1.7, you need to change this to 1.7 and so on. But at this point, to start with, if you're a beginner, I would recommend that you stick to this TensorFlow 1.5 with Python 3.4. This is tried and tested and it works. Okay, just a word of caution that just by changing these versions, the whole thing will not work. There may be other places where you may have to, some of the steps may change. So just a word of caution that just by changing this, if you want to try out with a different version, some of the steps may also change. So you don't think that just by changing this one particular command you will be fine. Okay, so that's been my experience. So to start with, I would recommend use this particular combination. All right, so it looks good. TensorFlow 1.5, and let me just reconfirm with my notes, and I think it looks good. So this is install, ignore, 1.5, CP34, and so on. Okay, so let's hit enter. So it started the process. Again, this might take a little while, so we will pause the recording and then get back when the installation is done. Okay, so looks like this installation is done, and as always, let us exit and then come back. Now you're currently in the environment. virtual environment. And it's a good practice before you exit out of the terminal to come out of the virtual environment. So just like you did source activate, you need to do source deactivate and the name TensorFlow. Okay, you will come back to the original command prompt, and then from here you can do an exit. Now we need to validate whether the TensorFlow installation has gone through properly or not. So the way to validate is to first start Python and then import TensorFlow library, see if it imports without error. So that's the best way to validate. So we'll open a terminal, and whenever you want to get into the environment, this is how you have to do. Come to environment and then say source, and obviously you can also use existing. So source activate TensorFlow. Okay, so we do this, and you need to run Python from here. And remember, you should say Python 3 because you have installed Python 3.4. Now here, when you say import TensorFlow as TF, when you get back a prompt like this without any errors, that means TensorFlow installation has been successful. If TensorFlow was not installed properly, you will get an error saying TensorFlow is not available or module doesn't exist or something like that. So TensorFlow installation is done, but now we will go through the process of installing Jupyter Notebook so that you can do your development. So let me just exit, and in order to install your Jupyter Notebook, which is going to be your development environment, we will first install IPython using conda. So conda install IPython and then pip install Jupyter. So let's first do the IPython. Conda install IPython. Again, it will ask you a question saying these are the components. Do you want to install? You just say yes. Alright, you say yes, and then once again it will take a little while, so we might pause the recording and come back once it is done. Great, so that did not take much time anyways. So we will, as usual, we will exit, which is source deactivate TensorFlow, exit, and then we will start a fresh terminal in order to install Jupyter. Now, in some places, they may say install Jupyter using pip3, but in my experience, it did not work with pip3, and that's the reason we will use pip. However, just keep in mind, you need to first go to the environment. So source activate TensorFlow, and you need to use this command, which is pip install Jupyter. Usually when you're on Python 3, you use pip3. But as I said, it did not work, so in my experience it works with pip install and not pip3. So pip install Jupyter. I hope you already noticed that it is JUPYTER and not JUPI. So again, it's probably taking a little while. We will pause the recording and come back once it is done. Okay, so Jupyter installation is also done. Once again, you need to, it's a good idea, not you need to, but it's a good idea to come out of this terminal session and then start afresh. So we exit, and we have a fresh terminal already available here, and we will once again go to TensorFlow, and we say Jupyter Notebook. That's how you start your Jupyter Notebook. So this looks good. Now, only thing is, since we are running for the first time, what you need to do is, if you come back to your command prompt, it will show you that if you are running it for the first time, it will say that you need to copy paste this link. So you can just, for the first time, only once, you need to do this, copy this and paste it in your browser. And remember, this is only the first time when you're running Jupyter. You need to do this. Subsequently, you don't have to. It will automatically open up. Alright, so now that we have Jupyter installed and it starts up, we need to test whether TensorFlow is working fine or not. And in order to do that, you can create a new notebook and you say import TensorFlow as TF and shift enter. If everything is fine, TensorFlow is installed properly, you don't get any errors, and then it works fine. This is an indication that TensorFlow got installed successfully, and that's about it. So that's all about installing TensorFlow with Python 3.4. So remember, this is installation of TensorFlow 1.5 with Python 3.4 on Ubuntu. And once again, in case you have a Windows system, in fact I have also done it on a Windows system, you can use VirtualBox to create a virtual environment, Ubuntu environment, and then follow these steps. And there are tons of videos to create VirtualBox, and that's the reason we have not included those steps in this. And if there are any comments, there are better ways to do this, please mention it in the comment section below, or if you need any further help, just mention it, and with your email we will respond to you. Now, what are the various elements of a TensorFlow program? As I mentioned, TensorFlow program is slightly different from regular programming that we do. So even if you're familiar with Python, this may still be new for you. The way you write a TensorFlow program is different from the regular Python programming that you would have done, or even machine learning program. You would have written some machine learning program using scikit-learn or regular Python libraries. This is different from even that. So let us see what are the various elements. So first of all, the way we handle data inside of a program itself is a little different from how we normally do. In a normal programming language, a variable is a variable in your program, right? So you have anything that can keep changing, you just create as a variable, or even constants in fact are actually created as variables. But in TensorFlow, the storage in the program consists of three types. One is constants, another is variable, and the third is a placeholder. So, and there is a lot of difference between these types, and we will see how they vary and how they are used and so on. So constants are like variables which cannot be changed. So for example, if you define a constant like this is how you define a constant, by the way. The simplest format is like this, like for example, b is equal to tf dot constant, and then you give a value here. A slightly more advanced version is you also specify the type. So you say tf dot constant 2.0 tf float 32. So the type is of type float. Now, in case of constants, you cannot, during the computation, you cannot really change these values. So for example, if you want to change the value of b from 3 to 5 or any other number, it is not possible. So that is the meaning of constant. Alright, so then we have variables. So variables we are all familiar with. What are variables? Whenever we use programming, we use variables. So this is pretty much the same. This is the way you define variables, tf dot variable. Now, one thing you need to note is this is the only type in which we have v capital. Okay, constant has c, small c, and placeholder has small p, but variable has capital V. And tf dot variable, and then you give a value, and then you can specify what is the type, and then you can use the variable, change the variable at any point in time with a different value and so on. You can update the variable and so on. So we will see all of this in the code. I will illustrate how a variable is defined and how it can be changed, whereas a constant cannot be changed, and so on and so forth. And then we have placeholders. Placeholders are really a special type, and this may be something completely new for many of us who have been doing programming, but in TensorFlow this is a completely new concept. So this is very important to understand this. Placeholders are like variables, but only thing is that they are used for feeding the data from outside. So typically when you are performing some computations, you need to load data from a file or from an image file or from a CSV file or whatever. So there is a provision with this special kind of variables which can be fed in a regular basis, because one of the reasons for having this kind of provision is that if you get the entire input in one shot, typically it may be very difficult to handle the memory and so on. So I think that was the reason they came up with this mechanism where you can feed in batches. And there is a certain way of populating the placeholder. We call this feed dict, feed underscore dict, and this is a parameter name, by the way. And you feed the placeholders, right? That is the meaning here. So there is a certain way of feeding the placeholders, and we will again see this in the example code as we move forward. Okay, so there are three types. One is the constant, which cannot be changed once you assign a value. Then you have variables, which are like normal variables we are all familiar with. And then you have placeholders. This is primarily for feeding data from, usually from outside, but of course you can also, for temporary testing purpose, you can feed within the program as well. But primarily the purpose of a placeholder is to get data from outside. So alright, so those were the constants, variables, and placeholders. That is how you handle data within a TensorFlow program. And then you create a graph. And once you create a graph, then you have what is known as a session. And then you create a session object, and you create a session, and then you run a particular computation or a node or an operation. And so typically